All right, let's look at operators in Java. Now, when we create an arithmetic or a mathematical expression, like 4 plus 3 equals 7, we use operators, operands, and know that it evaluates to a value. Now, in this example of 4 plus 3 equals 7, the operator, we have a single one, and that's the plus sign. We're adding these two numbers together. Our two operands are the numbers 4 and 3, and we know that this expression evaluates to the value 7. In Java, we have operators. They can be binary or unary. A binary operator operates on two associated operands. It sits in between them. A unary operator operates on a single operand, and it can be before or after that operand. Now, we have these operators for the integers, and they're all binary. And they are our standard addition, subtraction, multiplication, and division, symbolized by the plus, minus, asterisk, and forward slash. The last symbol is the percentage sign, and that's the symbol for the modulus operation. When I modulus or mod something, I find the leftover after division. So if I were to mod 5 by 3, I would have the leftover 2. That's the value that would be returned to me. If I were to mod 14 by 13, my leftover would be 1. That's what would be returned to me. If I were to mod 3 by 5, the leftover would be 3. That's what would be returned to me. Now, when we use the division operator on integers, we can have returned to us unexpected results. If I declared three variables, all of type int, a, b, and c, giving a value of 3, b a value of 2, and no value associated with c. If I then divided a by b and put that resulting value into c, I would find in c the value 1, not 1.5 as I would expect when I divide 3 by 2. And that's because when working with integers, when I divide an integer by an integer, the value that is a decimal value is truncated, not rounded, not returned, but simply truncated off. Now, I might think that I could solve that problem by declaring, in this example, the value c to be of type double. And so I would think, well, if I divide a by b, 3 by 2, I'll have returned 1.5. I'll put that into that double space c, and I'll be fine. But if I were to look into the space c that has been declared double and has had placed into it the result of a divided by b, I'd find that I would have the value 1.0, the double representation of the whole number 1. And I have this because when an integer is divided by an integer, what is immediately returned is an integer, the truncated value of that division. So even though I provided a space of type double, what was returned to me immediately on that division of 3 by 2 is a whole number, is the value 1. And so it was put into the space c that is of type double. And as a space of type double, a decimal value was given to that return value, and it's 0. So when I get back 1 from 3 divided by 2, and I put it into the space c, I have 1.0, the double representation of 1, stored in that space. Now there are a number of ways to get around this problem of integer division. The simplest might be to declare all of the variables to be of type double. And so if I had a and b and c all of type double, when I divided a by b, I would have returned back to me a double, and I would put that into space c, and I would have that 1.5 that I expected. Or I could use casting, and we'll talk about casting later on. But in essence, what casting does is it asks a value, a number, to pretend to be of a different type. And so I could ask a or b or both to pretend to be of type double. And so that when I had my division, 3 divided by 2, my compiler would see a double and a double, or one double or two, however I coded it, and it would return, therefore, a double. There are a number of ways, as I said, to deal with integer division. In this lesson, I want you to just be aware that it is an issue as we process numbers, as we build expressions in Java. Now, floating point operators are available to us also, and they are also binary, and they are our standard addition, subtraction, multiplication, and division. And we do have the modulus operator available to us, but we really don't use it that much in floating point numbers. Now, there are also a number of unary operators, and they associate with a single operand. Now, I have a negative sign and a positive sign, and they do just that. They, with a negative, will flip the value of the associated operator, so it will return its negation. So if it's positive, I'll get a negative. If it's negative, I'll get a positive. The positive sign, the addition sign, flips the value of the operand associated with it. So if it's negative, it becomes positive. If it's positive, it stays positive. And then the two last symbols, two negative signs and two positive signs, are my increment, that's the two positive signs, and then my decrement, that's the two negative signs. And what they do is they decrease, in the case of decrement, the associated operand by 1. In the case of the increment, the two positive signs, I increase the associated operand by 1. So those are my increment and decrement operators. Increment is the two plus signs, decrement the two negative signs. Decrement, I decrease by 1. Increment, I increase by 1. Now, I of course have precedence and associativity, and Java follows the rules of all mathematics. Now, we'll see at the highest level of precedence, we have the unary operators of the plus, minus, increment, and decrement. They work on unary. They are a unary operator. I then have multiplication, division, and modulus. They are binary, and they have an association left to right. Remember that those unary operators have no association, have no associativity. They only work with a single operand, so associativity is not applicable. But my multiplication, division, and modulus associate left to right. They're binary. They work on two operands, the operands on the left and the right of those operators. And then at my lowest level of precedence, I have my addition and my subtraction, and they associate left to right, and they are also binary. Now, parentheses cause an explicit change in my expression, in the processing of that expression. So it can override the order of operations, and it has the highest precedence. In conclusion, we've looked at expressions and operators, integer and floating point operators, precedence and associativity within our operators, and the use of parentheses.